Metacoder's new tools for deep learning models for drug repurposing. So you start here by choosing to create a model, and you can either find potential drugs for a given disease or potential new disease which a given drug will be able to treat. We're going to start by looking at diseases and try to find new drug candidates to treat these. So let's say that you wanted to treat an asthma attack, and from here you can choose your pre-processed data sets or run directly from models or from raw data. We're going to choose a set of these modalities, and we're going to look at most of the factors affecting the drug but leave something out. So here you're able to build your deep learning model where you can customize your association models, your feature extraction models, and then your final learning layers. We're going to run with a large multimodal autoencoder and a large variational autoencoder. Here you can fine-tune your parameters and submit the model. So now this model is training, and we can look at the pre-processed data. Here you're able to see similarities between drugs on the various modalities, where between pyribytol and exopronolol, you can see the different similarities on each of the metrics. If you wanted to explore the similarities between other drugs, you can just click here, navigate. If you wanted to look at the top most similar drugs on other statistics, you can navigate that all here. Here you see the first step of our model, which is the embedding layer, which is run. So these are the results and a little bit about the model architecture of this given multimodal autoencoder. In the time that we were just talking, it had trained 210 million parameters to better predict what drugs could be suitable candidates. Here you're able to see the FDA-approved drugs already and how they compare to each other on a TSNE chart. Same view, but in the 3-dimension case. Continuing. Here you're able to see the deep learning layers for the variational autoencoder and the results of the given drugs that are FDA approved and the other candidate drugs. Some information about this modeling layer. Finally, you're able to compare the drug predicted scores with that of approved and unapproved drugs across both the training set and test set. Here for an asthma attack, you can see there are several suggestions of high scoring unapproved drugs which could be potentially effective. Here you can look for the number of false positives, which really are drug disease repurposing targets, which could be effective. So from our holdout sample, we were able to see that this pair was above the threshold. A false negative is a drug that could suggest that the treatment is not effective. So here, all these low-scoring blue drugs are treatments that are approved, but according to the model are not potentially the best treatments. So here you're able to see the highest scoring drug disease pairs across all the combinations of drugs and diseases, which there are over 1 million of those. And this is how you use Metacoder to make recommendations for a new disease target. Hope this was informative, and enjoy your day.